Hi there, my name is Egil Kummervold. I'll talk to you about our Norwegian BERT-based transformer model and how we have used the resources at the National Library of Norway to build a corpus large enough for training such a model. I'm doing this work together with my colleagues Javier de la Rosa, Freddy Vetjen and Svein Arne Brygfjell. We are all at the AI lab at the National Library of Norway. Transformer models, or what some people refer to as BERT models, is general language models that are trained basically by trying to predict mask token in the huge data corpuses. I will not go into details exactly how these models work. I just want to briefly mention what is generally thought of as the advantages and disadvantages of such models. Firstly, they are extremely flexible. If you have a general transformer model, it can, with relatively little annotation data, be used for tasks like classification, named entity recognition, question answering, and so. And, as I'm sure most of you know, they are currently getting state-of-the-art results in all these fields. However, they do require considerably computing power and a very large amount of text. In this project, we have been so lucky to receive considerable computing resources from the Google TPU Research Cloud. With regard to corpus size, there are some advantages by being located at the National Library. I talk more about that later. As of early 2021, English BERT models have showed amazingly results, and new monolingual models like Albert, Roberta, DBERTA, etc. are doing even better. BERT, that was released in 2018, is supporting several low-resource languages like Norwegian, for instance. However, the results of these multilingual models are far from the level of the large monolingual models. And it has turned out that the biggest bottleneck here is the corpus size. In this project, the main goal has been to build a corpus that is big enough and to try to train on that corpus to build what we are calling the NB-BERT base model. It's a medium-sized transformer model that is built on top of the MBERT weights. So we continue to train on the MBERT weights. And we can try to continue training on the MBERT weights while we try to keep the multilingual capabilities of the model. One reason to do this is to create a reference point for future models. It's not supposed to be sort of the final model that we're building. At the same time, we are trying to increase the public knowledge about transformer models, and we have, during the project periods, published several collabs for using this model and trying them out on your own dataset. So, what's a large corpus in this sense? Just to give you a rough idea here, the Encyclopedia Britannica is 40 volumes of text, a totally 300 megabytes of uncompressed data. If you read everything, it will roughly take you 1 year if you read 8 hours a day. The Norwegian part of MBERT is actually 3 times larger than that, but it's still not 1 gigabyte of uncompressed text. The English BERT, however, the original model, both the base model and the large model, was trained on 16 gigabytes of text, mainly consisting of the English Wikipedia and an open book corpus. However, even this seems to be a bit too small to train a really great transformer model. Facebook's Roberta model was released roughly a year after Google's BERT model, and it was trained on 160 gigabytes of text. And Facebook proved that this increase in the corpus size was the main reason for Roberta performing better than the BERT model. Unfortunately, there are not enough available resources for low-resource languages like Norwegian on the internet. We have to look at other sources for building a corpora that's actually large enough for training a high-quality transformer model. And our main source for building this corpora is the scanned books and newspapers at the National Library. A main part of this project has been to transform what's known as the METS Alto files, that's OCR scanned text at the National Library, into files that can be used for training a transformer model. This process consists of several steps, but one of the main steps is to filter out the text that does not have an OCR quality that's high enough for including into the corpora. And the main aim is to get consistent text that is readable and that can be used for training a large transformer model. All in all, we were able to create 109 gigabytes of Norwegian text for the first version of what we call the Norwegian Colossal Corpora. As you can see from the graph, it's a very large source of this is OCR scanned books and OCR scanned newspaper. It is not as big as the Roberta corpus, but it's still quite a lot bigger than what was used for training the English BERT model. We have not actively filtered out non-Norwegian text here, though the majority, of course, is Norwegian bokmål and Norwegian nynorsk. However, there is as much as roughly 4% English text, and there is 1% of the corpus that is in other languages, mainly Swedish and Danish. I'll discuss a bit later what is the consequences of this, but we do not think that it will hurt the final model. Here are some of the main results that we are presenting in our paper. We were able to improve considerably from mBERT on all the benchmarks that we had available. We are mainly here testing on 2 token classification tasks and 2 sequence classification tasks. On the named entity recognition, the NER task, we have as much as 7.5 point improvement on the F1 score for bokmål. The improvement on the F1 score for the post set is a bit smaller, but at the same time there's quite a lot of ambiguity in this dataset, and it might be hard to improve very much more on it. We're also seeing good results and good improvements for the 2 sequence classification tasks that we have available. And maybe even more interesting, we seem to be able to keep the multilingual abilities of the model, at least most of the multilingual abilities. This is for the NER task. That's the only test where we are able to compare across languages here. We are also, just for a comparison here, including the English BERT model. And you can see that on English it consists of 4% of the text that is in our dataset. We are able to improve from the mBERT model and actually up to the same level that the English BERT-based model. We also are improving from the mBERT model on both Swedish and Danish. It's actually a bit surprising because there are not more than roughly 1% of Swedish and Danish text altogether in our corpora. The model is forgetting a bit with regard to here sort of two example languages, Spanish and Finnish, that we are pretty sure there's almost nothing of in our corpus. You can see that the F1 score on the NAIR test drops a couple of points. At the same time, you can probably also prevent this by just including a small bit of these languages also in the training corpora. The main conclusion from the project is that size matters. You're able to improve considerably for Norwegian. That was the main goal for our project. But we're also improving for English, Danish and Swedish. That was a bit more surprising since these languages are fairly sparse in our corpus. But the main reason for this is simply the size of our corpus. By all means, we are not the first one to point this out. These kind of models can still be improved quite a lot by just adding more data. And actually, a bit more surprising, this seems to hold true also for a BERT-based model. Remember, this is, when we're talking about transformer models, a relatively small model with roughly 100 million parameters. A BERT large model is 3 times larger, with more than 300 million parameters. And there are other transformer architectures out there with more than 1 billion parameters. If increasing corpus size improves the base model, increasing corpus size will benefit larger models even more. At the same time, even if we are getting results that are better than the MBERT base here, we are still not seeing results close to what should be expected for a large transformer model. A few words about our plant. As you might have guessed, we are planning on training a larger BERT-based model. We have, however, not exactly decided what architecture to use, whether we will build on a traditional BERT large architecture or if we are going to choose some of the more modern architectures out there. We will decide within a month. We are also considering training an autoregressive or a sequence-to-sequence model based on the corpora that we have. We are working fairly hard on improving the corpus. We are also trying to add other large sources that are currently not in the National Library. We are working on making at least part of this corpus openly available from everybody. Unfortunately, it's not at the moment possible to make the entire corpus openly available for training, but at least in our version 2 it will be a clearer marked what is openly available and what's not openly available. As this project has shown us fairly good is that we need to improve on the benchmarks for evaluating these models. And if anyone else is working on that, we will be very happy if they could contact us. We have a GitHub page available both for the lab and for the Notran project. The Notran page has a link to both the model in Hugging Face and also quite a few Colab notebooks that can be used for testing the model. The page also has some information about the project and a more thorough description of the corpus. I'm looking forward to your questions. Thanks a lot for listening.